Good day. In this video, we are going to examine solving some of the more complicated or advanced style quadratic equations. Keeping in mind, we want to do some thinking on the front end with mental sketches, and we want to do thinking on the very other end in terms of whether or not our solutions are correct or meaningful. In this case, the challenge might be making a mental sketch that's useful for us, especially looking at the right-hand side. We haven't had a lot of practice with that. The left-hand side is pretty straightforward. It's a linear function with a decreasing steep slope. In fact, the y-intercept is 7, and since the slope is negative 7, we're going to go down 7 over 1, so I also know the x-intercept of that line. On the right-hand side, we have what will be, if I FOIL this out, it's going to be quadratic, so I know that. But in factored form, you may or may not recall that the factors of a quadratic function will reveal the x-intercepts. When x is negative 1, which I recognize, or sorry, when x is positive 1, here we're going to get one solution, x-intercept of the left-hand side, right-hand side. And here when x is negative 2/3, we'll get another 0, which is somewhere over there. I know it's going to be a parabola that opens up because the lead coefficient is going to be 3, and so that's the sketch. So what I know from my sketch, just by thinking about the question right off the bat, is x equals 1 is a solution. I could tell from the graph, and I could even tell by substitution. I put 1 in for x, I will find 0 equals 0. Absolutely true. Now, I do know there will be another solution, and thanks to this sketch, I can be clear that it's going to be negative, and it's going to be more than negative 1, because that's, out here somewhere. So the rest of our task is to do the algebra and see if we could actually get 1 plus a negative number, 1 and a negative number as my two solutions. So to begin, the only thing I can think to do is to FOIL this out on the right-hand side. So I get the equation into quadratic form. So I do that. I collect like terms. That's done. And then I subtract 7 and add 7x to both sides, and I get the quadratic equation in this form. This equation, most people would try factoring right away, or the quadratic formula right away. But if you're paying attention, you'll recognize the coefficients are 3, 6, and negative 9. Each of these is a multiple of 3, so if I divide both sides by 3, I get a much easier equation to look at, a much easier equation to factor. Even to see that it's factorable is pretty straightforward. So I can go straight to the shortcut, get my two factors, find my two solutions. I've already proven that 1 is a solution. Now I just need to make sure or verify that negative 3 is the other one. Certainly consistent with my graph up here, but when I do all the number crunching, I get 28 equals 28. So when x is negative 3, both the left and right hand sides will be equal to 28. So negative 3 is indeed one of the two solutions to this equation. Finally, we have this equation, which is a little crazy. It doesn't look quadratic at all. Going back to work in the third quarter, we learned how to graph reciprocal functions, 1 over x. We just shifted that graph to the left 3, so this is negative 3x, x equals negative 3 rather. And I made a point of noting that when y is 1 over here, which means our y-intercept is going to be less, it's going to be about 1/3. To graph the other function, I'm looking at shifting the 1 over x graph up a quarter after it was reflected over the x-axis. So I'm going to get this purple curve. Notice the dotted line at y equals a quarter crosses the y-axis slightly below 1/3, so that's why I needed to know that number. When I graph, I can see there's going to be one positive solution. It's going to be a bigger number, and there will be one negative solution. And one thing I know about my negative solution, it's going to be somewhere between 0 and negative 3. There's no doubt in my mind about that. And where exactly is it in between there? Well, that is yet to be determined, but at least I know if I get a solution that's out here at negative 5, I have to be wrong. There's no way that's ever going to happen. So, now for the algebra. When I write out the equation, any equation with variables in the denominator, that's the thing I want to go away. So what I'm going to do is multiply both sides of the equation by a denominator that each of these denominators, by a number, sorry, that each of these denominators will divide equally to. For example, on the left side, x plus 3 divided by x plus 3 is 1, leaving us with 4x times 1. Over on the right-hand side, when I distribute, now remember I have to distribute this, multiply this set of factors into both of these terms. In the first case, x divides into x, leaving me with 4 times x plus 3 times negative 1. So that's how I write it. And then here, the 4 divides with the 4, leaving me with 1 times x plus 3 times x. So when I distribute the negative 4 and I distribute the x, I get this, which is starting to shape up like a quadratic. Collecting like terms and subtracting 4x from both sides gives me this quadratic form, which looks like it wants to be factorable, but it is not factorable. So I continue by using the quadratic formula. I write down the formula to jog my memory. I put all the coefficients into the appropriate places and begin the simplification process. Lucky for me, 73 is prime, so there's no further simplification necessary for this exercise. So all that's left is actually verifying that I'm correct. So what I need to do is first recognize the square root of 73 is, well, it's less than the square root of 81, which is 9, and it's bigger than the square root of 64, which is 8. So I'm going to guess that this is going to be around 8.5. Now that's not a good estimate, but it's good enough for our purposes. It's 5 plus about 8.5. over 2 is going to be about 6.3-ish, maybe. Actually, I probably did that wrong. It's probably closer to 6.8-ish. And then here, 5 minus 8.5 is going to be around, well, I just said more than 1.5 and negative. So these are my approximations, which are consistent with my sketch. And if I have any hesitation, I could either A, put one of these solutions back into the original equation, which would be a fun test for some of you, or B, I go to Desmos and verify that these are correct. And I'm definitely in the right ballpark with my estimations. Even if they're really terrible estimations, I still have a lot of confidence when I look at the graph and my estimates. So that's what you need to do to be successful at this class. Good luck and have a great weekend or day or whatever this is.